The VR Bone Lab will be used to teach osteology lab skills to second-year anthropology undergraduate students as part of the Reading the Skeleton module. Part of the learning objectives include the ability to identify and describe normal skeletal anatomy and how to use methods of age and sex estimation. The RAG-LLM integration described here is initially developed for use in the VR Lab's Bone Inspector. This allows students to select bones for inspection and enter a focused environment offering a selection of tools, including movement, scaling, cross-sectional cutting, and colour manipulation. Staff and student focus groups identified a need for customised assistance to enable students to ask questions about the bone in the inspector. What is the diaphysis? The RAG-enabled LLM integration developed allows students to submit natural language queries to the LLM provider.
The diaphysis is the long, slightly curved shaft that makes up the central part of the humerus,
and receive detailed narrated responses tailored to the activity and bone they are working with, through instruction and context injection added to their query when it is submitted to the LLM. This enables the student to obtain contextual real-time guidance in the immersive VR environment. This is the primary contribution for this project, enhancing the RAG system by including specific context related to the user's current task and experience. It's also a practical application, that is, it's intended for use in the curriculum context rather than as a purely experimental exercise. The system is built on a modular architecture, and it combines MetaVoice SDK for natural speech interaction, Eden AI's multimodal LLM integration, context-aware response generation, and a rate limiter to manage the API calls for both dictation and text-to-speech. At present, the user activates the assistant through a tab on the hand menu, which is gaze responsive, and uses the UI pointer to activate the microphone and obtain the transcript from the dictation service. When the user is happy, they can select the Send button to submit the query. The dictation system uses an autocorrect feature, but the LLM is very good at accurately interpreting ambiguous queries. The Eden AI service includes persistent data to form the RAG knowledge base, and a base level of instructions that detail the way the AI should behave. The setup includes the temperature setting, which in this case is set to 0 to limit the responses to the included data. The context in this situation is obtained from the bone object. Bone objects include a reference to a scriptable object, which provides details for the specific bone loaded into the inspector. AI context pairs consisting of a context name and a text string provide the description. This approach means that the context is sent in a structured way. Instructions can be sent from any object, and the context manager compiles them into a list. This is initially set by the bone object at the moment, but any object that raises an event indicating it has context or instructions available will have that data added to the context manager, and the active instruction can be set manually by index or by name. The user can leave the environment and select a different bone to inspect. Eventually, we may also include a library function to allow in-scene object swapping. Our testing so far has been with an unoptimized set of persistent and object context, as our academic partner considers how to best phrase instructions and object context for the VR environment. However, a test set of 12 queries generated with 3 different object contexts shows a 92% acceptability using the suggested scoring scale mentioned by Nemeth et al. While this feature is complete, we will extend and develop it in the future. The next phase of development includes expanding the persistent context set, fine-tuning the object-specific bone data, implementing multiple switchable instruction sets for specific activities, and integrating input and responses with a character-based dialogue system and activity tracking.